This is a UPS. Uninterruptible power supplies are very attractive because they contain within them a charge controller and an inverter and a whole load of plug sockets all in one handy box. And of course, the question that gets asked about these an awful lot is, can these be integrated into a home power solution? Well, yes they can. Now these things, as I say, are surprisingly simple in the way they operate, and there's in fact only three ways. Okay, there are only three methods: standby, line interactive and online. Now standby is the cheapest and the most cost effective. It's just a rectifier charging a battery. When everything's good, you get the power through the utility line. Something goes wrong, of course, the transfer switch switches. And when it's switched, we get the power from the battery through the inverter. And as I say, this is the simplest method. The next one is line interactive. It's actually identical to the first one, but it does provide additional support. Now the additional support is through AVR, automatic voltage regulation, so it protects against surges and frequency changes. Apart from that, it operates in exactly the same way. Third and the last is called online mode, also double conversion, because the UPS converts incoming AP power to DC and then back to AC while charging its internal battery, providing the ideal output power. When the utility fails, it switches to the battery mode to keep loads operating. The bus supplies buffer energy to prevent total energy drop during the switching operation, and this results in zero transfer time. When the quality of utility power is good, the UPS switches to bypass to increase system efficiency. It's commonly used to protect critical applications like data centers and communication, that kind of thing. So it's mildly embarrassing I'm doing a video on how to use this because it is so simple to use, but there's so much nonsense out there that I thought a video to talk about how to actually use it might be useful. Now invariably they come in a sealed closed package, and on the back of this one, which is an APC 400, which means it's 400 VA or 250 watts, is this. There's a little slide, and when I take that slide off, what I'll do is I'll expose this tiny battery here. Now this thing can be bought on Amazon for about £54, and this thing, which is the original battery, is about £50. So replacing that little battery, which is designed to last, I don't know, 10-15 minutes, because these things are meant to be used for you to shut your computer down safely should there be a power failure. So they don't last very long, and of course what most people want to do, and certainly in a home power situation what you want to do, is put in a bigger battery. So can you put in a bigger battery is the first question, and the answer is yes. You pull the back off, remove the battery, you'll see your black wire, red wire, and you extend them with battery terminals to fit your bigger battery. That, quite honestly, is all you do. And I've plonked my terminals onto my bigger battery, and because this battery is 7 times the size of this, suddenly this has 7 times the amount of energy stored. And that's all there is to it. There you go. All I've done is extend those wires and stick them on there. Now of course a couple of questions arise. One thing is, bigger battery. Is it going to draw more current? Well, that's why these things are stupid. These things can't recognise the current. They can only recognise the voltage. So they will charge that battery at the current designed to charge this battery. So it'll actually take 7 times as long to charge this battery. But it won't draw more current because it's got a protection circuit in to stop it doing that. It will just try to charge that battery at whatever current was fixed for this, so it'll take 7 times as long to charge it. And of course that can be dreadfully slow. And we've got one on here, we could actually put 100 on there if we wanted. It would just take a million years to charge them. So it takes longer to charge the battery, but it won't damage this by overdrawing current because it can't recognise the current. It only recognises the voltage, and it has a fixed current that it can feed into the battery when it's utilising the battery charger bit of what's in here. Now I don't have an issue with that on the whole. I don't mind if it takes forever to do that. But if you do think that's an issue for you and you want to charge the battery separately and then hook it up, I'll put a flip switch in there. Use a double pole isolator switch. You flip it in one side, it goes to charging. You flip it in the other side, it goes to here, and you're only using the inverter section of this. Well, that's okay. You can use the inverter is a very good inverter, and you don't need to use the charging circuit at all if you don't want to. If you want to use the charging circuit, then you have that limitation in time, because it'll take longer because the battery's bigger. Now, when you charge it using the battery charging circuit, then obviously you've plugged it into the mains, and it's taking the main supply here. This is designed to operate between 180 and 260 volts, so you have to feed in 180 to 260 volts AC from your charging generator to utilize the charging circuit in here, but not to utilize the inverter circuit. So you could have a separate charger unit, like one of these, a smart charger. This is a fast smart charger. It will charge that battery in about 4 hours. You could have a separate charger unit if you wanted. You could make sure that your input here from your generator is 180 volts plus at 50 to 60 hertz if you wanted to. But there are loads of ways to charge a battery separately. A battery will charge a battery. Remember, these charge around about 13 volts or so. So if you have something in there with a DC current greater than 13 volts, like 14 volts, it'll charge the battery. So if your generator is outputting 14, 16 volts and you stick a diode between the generator and the battery, you can directly charge the battery from the generator without using the charging circuit in here at all, should you wish to. So it's quite adaptable in what you can do with it. You basically can extend it just by doing exactly what I did. If the charger in here is an issue to you, then you can add a charger circuit on it, which is little more than a capacitor and a diode, remember. You can add that to it and put it through a flip switch. So flip to charge, flip to discharge, and you can make that automatic. Those circuits are available for about 80 pence if you want. So that's not really an issue to my mind. I mean, it does take a little bit more working around, but the understanding of the electronics is nothing at all. It's a practical thing that you need to understand, and it's really down to what limitations you actually want it to be. But like I say, this will charge from here. It just takes forever. So we plug it in. It's on, green light. It's now charging that battery, no problem at all. If we unplug it, so it's now disconnected. So we're now running purely off the battery, and it has that irritating beep. So one thing I would do is snip the speaker, just so I don't have the irritating beep. And I can plug any piece of equipment I want into this to make this thing work. Now this thing, its output is limited to 250 watts, and that's just to do with the circuitry and what the circuitry can handle in there. So you're not going to be able to run your blast furnace from this. You're going to be able to run a piece of equipment that's 250 watts or less draw, which is what your computer is basically. If you want the larger ones, of course the larger ones are available. You can get this 750 watts and set you back about, it's about £100, £150, something like that. It's going to be a question of what you need, but if we plug in a bit of AC equipment, there we go. There's my 240 volt AC Rheingold meter, quite happily running from this inverter section here. So I can use the inverter section all by itself, and that inverter of course is drawing its power from this battery. Now this will last a very long time because this is 7 times as big as this. So it's very easy to use these things. The things actually consist of nothing more than extending to the battery. You don't have to worry about the current draw. The current draw is going to be what's fixed in here for the small battery, and it's not going to draw any more. That's an issue for you. Then you need to arrange another way to charge it, which can be very simple indeed by connecting it directly to your generator if you want. The inverter section is going to happily run anything up to the rating of the inverter section. And like I say, it's almost embarrassing to make this video because there isn't anything else to know when it comes to using these things. Now there's plenty more to know when it comes to understanding these things, and if you want to delve into the electronics and make some adaptations inside that pretty plastic box, then yeah, you're going to need to know an awful lot about it. There is another thing about these. Now I was quite lucky in that I was just given this and it's perfectly functional, but it's a product issue. These things are made with a bank of capacitors to feed any spike current that your machine might want. So say you're running a blender, for instance, it's going to spike to begin with, and the capacitors take care of that. It's a product fault in that those capacitors do tend to blow, but that's nothing to do with this, it's to do with the product itself. So if you've got one that has that as a known issue, you're probably better off buying one or getting hold of one that doesn't have that as a known issue. So that is one of the known issues about these things. But in terms of using that box to integrate into your home power, as I say, it's as simple as that. Now, what we tend to do, of course, is get an inverter that will run the entire house. I have the contention that's not a good idea. Why not distribute the DC around your house and have a smaller inverter at the point at which you want to apply a 240 volt or 120 volt supply to the piece of equipment that needs that. I mean, we could run our entire lighting system on 12 volts, as we know, in which case the amount of equipment you're going to need to run your 110, 120, 230, 240 equipment is going to be about 6 of these, something like that. And the power they're going to need with one plug socket, you're probably talking a few £100s instead of thousands of pounds. And of course, that brings in redundancy, because if one of these breaks, then you just replace that one, all the others will be fine. If you're using a big inverter and that breaks, well, you've got to replace a big inverter. So that redundancy and using an inverter at the point at which you use that is probably a way to go, and distribute the 12 volt, 24 volt supply around your house to run everything else at that kind of level. That's what I would suggest. Now these inverters themselves, these UPS, and using inverters as part of a home supply, it's nothing more than extending it to the battery, and don't worry about some of the nonsense that you hear. Anyway, I hope you enjoyed the video. I sincerely hope it was very helpful to you, and thank you very much for watching. Oh, please remember to like and subscribe.